Okay, we are recording now, I think.
Yeah.
Okay. Wait. Okay, so welcome to everybody to the third LeetCode community meeting. Today we have other two guys that will present, or maybe one guy that will present his thesis work, and another guy, Gabriele, which is here to ask something about some implementation details on his thesis too. And I will give the word to Francesco Torta that will present some news about the last LeetCode release.
Yeah, thank you, Francesco. And as we discussed in the last community meeting, we released a new patch release for LeetCode, especially 1.0.1. And thankfully, it's not a breaking release, no breaking changes, so don't worry. We just fixed some critical bugs that we had, like, for example, on the declarative peering, and some minor issues. Also, we added the support for Argo CD 3.0. Also, if you're using that, consider upgrading. And of course, as always, you can find the release notes on GitHub. And that's it for the release. If you have any questions, just ping on the Slack. And Francesco, if you want to present our guest.
Yes, Giulio is a student that has presented his thesis some days ago in Polytechnic and Polytechnic di Torino, and today he's here to present our work. His work, and Giulio, the stage is yours. Feel free to share slides, whatever you want.
Okay. Hello, everyone. Okay, I'm going to share the screen. Wait, I have to put this on full screen. Window. Okay, can you see?
Yes.
Yes.
So I'm going to present a part of my thesis about the first steps in the LeetCode security. Is a solution based on NF tables policy for restricting the traffic inside the LeetCode peering between two clusters. So I'm going to briefly introduce the technology that I used and the current behavior of this technology to the problem that derives from these behaviors, and briefly technical implementation details. So as we know, LeetCode peer-to cluster, and one cluster made the consumer part cluster, and the other one is the provider. And this is an unrestricted connection. So each pod on each cluster can contact each other. So the packet travels through LeetCode gateway and the VPN WireGuard tunnel made by LeetCode. For those that are not so familiar with NF tables, is a framework like EP tables, and an example is shown in the slide. So we have a table and a chain or multiple chain that applies some specific rule based on some needs. Actually, LeetCode uses NF tables under the hood to perform NATing and routing rules, but there is no actual support for filtering rules. I can explain briefly what is the current behavior of the two cluster period with LeetCode. So green arrows shows permitted and allowed connection. In this example, we have a consumer cluster that offloads a namespace in a provider cluster, and all connections are allowed by default. Also, Kubernetes allows by default all connection between all pods. So for example, the pod in the local cluster Milan with IP 10.10.1.2 can contact pods, offloaded pods like 20.30.1.1 and the local on their own provider 10.30.1.2. So all connections are unrestricted. And for another topology to better understand is when we have two consumer clusters that offloads on the same shared provider cluster. Also, in this case, all connections are allowed. So a local pods in a consumer cluster can contact local pods in a provider cluster, and other pods that are not that are not belonging to the cluster itself. So local Milan pods can contact offloaded pods by another consumer, another tenant. And maybe this is not always a desired behavior. So from there, there is what is the problem and the work that I've done in the past few months. I divided in two different topologies. The first one is the topology that I've tested, but the same consideration can be done with the consumer protection. So analyzing two different scenarios in a provider protection, we have again a single cluster consumer that offloads a namespace in a provider cluster, and we want to block the traffic that goes through that go to the local pods on the provider. How can be done? Applying NF tables directly in the Lico gateway. Another scenario is the same as before, and we can block by applying a default deny rule in the Lico gateway. So local pods can contact local pods of the consumer cluster can contact only offloaded pods of the same cluster, of the same consumer cluster. So in this case, we want that only local Milan namespace, the pods 10.10.1.1, will not be able to contact offloaded pods from another consumer cluster like Venice, like the pods 30.10.1.2. Some implementation details about the modify and changes that I have actually done. I modified the firewall configuration CRD that was already present, but again, it was supporting just NAT rule and routing rule. So I added some filtering necessary field like accept and drop to drop packet and accept packet respectively, and support for EP ranges and a counter for monitoring. This is a way to modify a CRD, enabling a declarative way to accept or deny specific traffic. In particular, red corner highlights what I changed. So again, we can accept or drop traffic and support different EP ranges. Of course, the reverse traffic just need the position reverted, so with DST field. And the counter is optional, but it's just for monitoring. So the result could be like it shown in the picture. In this case, we have two offloaded pods in the same namespace. So we want to allow the connection that has the destination with the shadow pods, with the offloaded pods, but we want to deny the traffic that has the destination to local pod of the provider cluster. So in applying these NF table rules at the Lico gateway, the table will be like this one. So default deny policy drop to deny all the traffic except for the traffic that has the destination of the EP of these offloaded pods. So 20.10.1.1 or 20.10.1.2. The same is in this picture, but with two consumer clusters. Since the policies are default deny policies, we just need to add exception for those offloaded pods. And this is the NFT tables, resulting NFT tables with just changing the EP. Of course, I encounter a little problem because I changed the API, the CRD, so I have to also edit and modify the webhook just to perform some checks for IP ranges that were not in conflicts, and some check about the counter field and the action field correctness. So a possible implementation, maybe we don't want always to manually insert pods. So a possible flow could be at peering time, we can apply an empty NFT table at the Lico gateway, and then after offloading pods on namespace, we can add or delete or modify allowed IPs inside this CR. Inside this CR. So during the reconcile, the rules are updated and stays up to date with the cluster state. In conclusion, the results obtained are like shown in the picture. So we block the traffic with indicated by the red arrows, and we allow the traffic indicated by the green arrow. So local pods can contact only pods that belongs to the same consumer cluster, and not pods that belongs to other consumer cluster, or local pods that belonging to the provider cluster. Thanks for your listening. If there are any questions, I'm here.
Thank you, Giulio. No, I have no question. I mean, we are not okay.
Sorry. I have a question. I was trying to understand how to raise the hand, but luckily he recognized my hand.
But we are not too much today, so
Yeah.
I think it's no problem.
We're recording. So my question is this rule applied only to the gateway, or you can actually apply those filtering rules in any possible node?
Technically, actually, are applied only on the gateway, because the labels that trigger the reconciles are specific for the gateway pods. But you could set up your personal labels and force a reconcile on whatever pods or also nodes, technically. But at this moment, for what I test, for the test done, I reconciled of the Lico gateway because it's the single point of connection between two clusters. So it was logical to put the rules inside the gateway pod.
Okay, so let's say that with default values, with default labels is applied only on the gateway rule. Just in case, by changing those labels, we can have Lico applying those rules in any other node. Is it correct?
Yes.
Okay, perfect. But do you see any value in applying this on a different node or not? Because
I tested, for the test I've done, I encountered a little problem applying the rules on the nodes directly, because with some CNIs can interfere with the CNI's normal flow. So maybe I could test better and more, but for the test I've done, it's better to let the CNI make her works, and you go along with that.
Thank you very much.
You're welcome.
Thank you very much.
Okay, so Gabriele, if you want to tell us about your suggestion for okay.
Okay, so hello everybody. During the last community meeting, I presented you my work on optimizing the direct connection between pods in offloaded in peered cluster using Lico. And I was told to change my implementation a little bit since I changed the code of the virtual kubelet. So I tackled the problem from the consumer perspective, and I was told to make it a webhook, a mutating webhook, so that this logic is moved directly on the providers. So at the update or creation of a shadow endpoint slice, this webhook would trigger, and we have told about automatic behavior or manual behavior, but I have some concerns about the design of this solution, because we need three things. The data provider cluster need to perform this change is the pod size. If you want, I have a few slides to so you can look at something. Okay, let me share. Okay, maybe you can see. Oh, I can. Where's the full screen? Okay. Okay, can you see? Sorry.
Yes.
Okay, so the idea, as I told you, is to have a webhook to change the addresses we have in the shadow endpoint slices. And what do I mean with change? As you can see, the red one address, this is a sample of a shadow endpoint slice in a provider cluster. As you can see, the red one is the address of the pod in the cluster at the other end of the connection with another provider. I remind you that the topology is made by a consumer with two providers, which are connected by the LeakyCTL network connect. So that the red address 10.70.0.5 is the address of the pod deployed on the other side of the shortcut, on the other cluster. Okay, and this leverages the external CIDR of cluster 1, which means that the traffic will go through a long route. Okay, and we don't want this, of course. So what I want to do is to replace that address with the correct one, so that when the real endpoint slice is created, that address is not remapped, and it's going to be used in the endpoint slice and in the services. Okay, so what do we need to make this happen? We need three data, which are the external pod CIDR of the consumer, and we needed to recognize which are the addresses going through the long route and not directly to another cluster. We need, of course, the pod CIDR of the shortcut to use it, and the host part of the pod on the other side. These information are not that easy to retrieve, because the first two are in a CR directly on the provider, which is networks, but the other one is only present in the consumer. So in order to fetch it, we need to make an API call to the API server of the consumer cluster. And this is not suitable, of course, for a webhook, which needs to be faster. And we also need some permissions and stuff like that. So I didn't like something like that. And this way is to make it automatic, let's say. Another strategy I was thinking about was that this data, or part of this data, especially the point 3, so the host part, is provided by the user by putting on a label on the shadow endpoint slice. This label change would trigger the webhook, which just needs at this point to fetch from its own API server but also to check if the user-defined address is correct and it corresponds to an actual pod. So there is something not cool either in this way. So I just want to discuss with you if you have some suggestion or some way to go, because I think the webhook is a great idea to tackle this problem, but I don't really see how we could do this.
I'm just certainly 100% agree with you that the webhook probably is not the better solution, but I don't have at the moment better solution in mind. Let me think.
Okay, so one thing could be like a proof of concept for this design, which I don't think could be production ready soon because of these problems, and maybe something I didn't consider also. So before coding, before the actual coding part, I wanted to make sure to have a good design. But if you are not sure, if we are not sure about it, maybe I can just try to code a mockup, a sample, so we can test if the performance are actually that bad, and in case we can maybe try to improve performance or do something in that terms.
I also don't like so much the fact that you need to contact the consumer API server from the provider. Also, these parts of the workflow is not so good, because the last time when I was suggesting you to use webhooks, for some reason I was thinking that the shadow endpoint slice was created in the consumer cluster, but obviously it's not that. It's created directly from the virtual kubelet to the provider one. So for some reason I was thinking that this logic was running in the consumer, but it's not that. So
And what about if we step back to the previous solution and we merge it inside the virtual kubelet? I mean,
yes, but
should be
the things that I wasn't liking so much is that there are probably can you hear me?
yeah.
Or there is a noise, okay,
Yes.
because there is a lot of noise, but probably WebEx is clipping it. Is that there was some custom resources that was synchronizing in a strange way between clusters, etc. We need to understand how the virtual kubelet can get the information from the provider. But okay, yes, I think that is a cleaner solution than this one that requires that the provider contacts the consumer.
Honestly,
sorry, in the virtual kubelet implementation, actually the flow is the opposite. Is that the consumer contacts the provider to get the pod cider of the shortcut. In my implementation right now, it relies on the work of Santo, who presented the last community meeting. But maybe we can do this just with some API calls to the provider. This time is the opposite flow, okay? But we need to have some permissions as well, I think.
If you are able to get this information from the remote cluster, yes, we adding the required permission. But if we add something that is inside the tenant namespace of the cluster, it can be something doable.
Okay.
I think so. I don't know, Francesco, if you have any ideas.
Honestly, I would like to have this feature inside Virtual Kubelet, just having a feature flag to enable, disable it. And maybe I was thinking about an annotation, a label, whatever. Maybe it's better an annotation to change the behavior when you know, and having an annotation that you can define on the service, which change the behavior. So you can select if you wanted the traffic pass from the central cluster, or if it can use the direct connectivity. Yes, that's Fulvio.
Why do you need this kind of annotation? Because the idea, from what I understood, is that the shortcut should be created explicitly, or explicit means also from a dedicated orchestrator or something like that. So if you create the shortcut, I assume that the traffic should pass over the shortcut. So why do we need a specific label to enable the traffic?
Because I think it's better to go step by step. Because if we don't put this label, the default behavior become okay, use the shortcut. And if we have some bugs, something that has not been tested, the risk is that everything breaks. If you enable this behavior with an annotation explicitly, you are sure that, okay, if something is not working, I can try to remove the annotation and check if it start working again.
Got it. Okay.
And then I think that in some use case, someone should be use Lico to have at the same time a direct connection between two clusters and the connection also with the central cluster.
But at this time, I wonder whether this kind of shortcut should be enabled, let's say, on a per destination base or something like that, because what we are talking about is either everything goes on the shortcut or everything goes on the central cluster. Is it useful maybe to have selections, so like something goes on the central cluster, something goes?
Yeah, the idea of the annotation on the service is for that, to have a way to select on the single service if you want the connection, the direct connection, or the connection passing through the central cluster. If you
Okay.
want, and if you want some more complex scenarios, for example, you can create more service. One service can use a direct connection, and the other the normal behavior link.
Okay, got it. So the annotation is on the service. I didn't get the point before. Thank you.
Gabriele, just one question, because I didn't understand much. What is the problem with annotations to pass data to the provider? Because I'm missing a piece probably.
It's the actual API call to the API servers. It's a really slow thing to do in a webhook. That should be fast. There will be several seconds before the operation is concluded, not considering the fact that we need to give additional permissions to the provider clusters, which maybe we don't need it. And it's not good for performance, I think.
Yeah, but the consumer has all the information, right?
Yeah.
So when it creates the shadow endpoint slice, why can it not annotate the shadow endpoint slice with all the data the provider needs?
The only reason was that we saw the past time that you needed to change the code of the virtual kubelet. So we are trying to have a solution that the virtual kubelet is not touched and we add only our book in addition to that. But if we need to change the code of the virtual kubelet, we can add a flag as Francesco was suggesting, and we can do it.
I don't see honestly a big issue of modifying the virtual kubelet, especially if we have the feature flag like Francesco suggested.
And we all already have some flags in the virtual kubelet to change the behavior of the AP remapping, like disabling it. So it's nothing new.
Yeah, we have tons of settings. So for that, I wouldn't be so much worried. And also another thing is why, like, I like the webhook idea, but why can it not be done on the shadow endpoint slice controller directly instead of passing from the webhook? Even though I understand also the webhook is cleaner.
It's the same issue that you are in the provider cluster with this controller. So again, you have the provider cluster that needs to access information from the consumer one. So that I think that is the main issue of this architecture, because the provider cluster does not have
yeah, but all the information are coming on the notations, right? So
yeah, but okay, but if we have the notation on the endpoint slice, we are okay.
Yeah, that's what I meant. Like if we go in this route, so we have all the notation with all the data. We can even not do it a webhook. We can handle it on the shadow
absolutely.
Because at that point, the shadow endpoint slice controller creates
only have to
the actual endpoint
override. Exactly. It has only to override the value with one of written generation.
Correct. So
okay, so just let me get it clear. You are saying that all the data that the provider needs should be passed by the consumer by modifying the virtual kubelet to add this data in the annotation, right?
Yes.
Okay, I like it. Okay, it's more or less what I have done, but not the same. Okay.
This annotation can be used either by a webhook or by the shadow endpoint slice controller. The only difference is that you will see the actual modification. Like if you use the webhook, you will not see how it's translated. If you use the shadow endpoint controller, you will see the original EP in the shadow endpoint slice and the translated EP in the endpoint slice. So maybe you can debug even more. You can see this translation. While on the webhook, it's a bit more hidden. And performance-wise, I don't think there is also a difference. So either way, I'm good with both solutions. I don't think there is much difference, but you can also consider that, and we can discuss it about it, of course.
Okay.
If we go in the annotations route, of course.
Okay.
I understand it's not the cleanest solution ever, but it would still work.
It's a way to make it work.
Exactly. So
at least. Okay, thanks a lot.
Are those answers enough for you, Gabriele, to proceed?
Yes, totally. Yes, because I started by modifying the virtual kubelet because I was thinking that that would be the best way, because the consumer has all the info to make this change happen. So I didn't see, since the route of using the webhook directly in the provider needed much info and much overhead, I wasn't thinking that that would be the best idea. So I wanted to stick with the virtual kubelet idea.
Perfect. So I would suggest you to open an issue and describe the problem, the solution, the possible solutions either also. So maybe we can think about it asynchronously, and we can reason it better. So
sure.
And we can also have feedback from other people's. So that would help.
Okay.
I don't think we have a Q&A today.
I think we have date of the next meeting
I don't remember.
in the agenda. I would propose to skip August.
I agree.
Makes sense.
Should we say the 1st of September, 8th of September, or even later? 8, maybe. And then we can make a call for possible contributions. I think we have also to define a little bit the roadmap because it's not clear from the website. The roadmap close to 1.1. Okay, so next meeting 8th.
Okay.
Fine for me.
Okay. Anything else? No? So thanks for coming and bye-bye.
Bye, thanks
Thank you.
very much.
Bye.
Bye.
Thank you.
Have a nice day.